All right, so your Pythagorean theorem is your a squared plus b squared equals c squared. Usually everybody remembers that, and that goes pretty well. Here's the only two things I want to say about it. Number one, it only works for right triangles, which is what we're going to be looking at. Okay, but it only works for right triangles. And C has to be the hypotenuse. It doesn't matter what order these go in, but C has to be the hypotenuse. Now, there are a few that are called Pythagorean triples. Well, more than a few, because numbers are infinite, so they go on forever. But I call them the locker combination ones, because they're going to look like little locker combinations. And there's 4 of them that I always bring up. And you, bless you, you can do what you like with them. I would try to memorize them, or at least 1 or 2. If you know them, it just makes your life a whole lot easier. So the first one, we're just going to write them off to the side here, is 3, 4, 5. And even if you refuse to memorize the others, could you give me 3, 4, 5? Like, you memorize that one? Okay, 3, 4, 5. So what that means is 3 squared plus 4 squared equals 5 squared. It fits this pattern, all right? The next one is 5, 12, 13. Do you see why I call them locker combinations? Like, that's just what it looks like. We got 7, 24, 25. And 8, 15, 17. So again, I'm presenting it to you. You're welcome to do what you will, but they do save you some time if you know them. And if you at least give me 3, 4, 5. You can memorize that one. All right, so let's do these first few. Looking at number 1, we're missing this side. Yeah, I'm sorry. I talk fast and write fast. You just got to yell at me when I go too quick. I apologize. I've gotten better over the years, though, because I'm from the north, which I didn't know until I moved here that the north was a thing. I just thought I was from Pennsylvania. Anyway, when I first moved here, I talked so fast no one could understand me. So I've gotten better. Better now. No. All right, so we're missing this side here. You can call it whatever you want. Usually people will call it A or B. Usually people will call it A or B. Some people like calling it X because we're used to that, like the missing thing is X. I'm going to go with A. Again, you can call it whatever you want. So we've got 4 squared plus A squared equals 10 squared. And then you just work it out from there. Now, if the numbers get large, I will reach for a calculator. If I put something like this on a non-calculator part of the test, I will make sure the numbers stay small enough that you won't need one, okay? It doesn't matter. You can write A squared plus 4 squared. No, thank you for bringing that up. If you want to write A squared plus 4 squared equals 10 squared, it doesn't matter. Those can go in any order because adding doesn't matter, all right? So 4 squared. It doesn't matter. It doesn't make a difference. And again, so you guys didn't listen to me. If you don't want to call it A, you can call it X. You can call it Q. I don't care. Like, you can call that whatever letter. Like, you're getting hung up on the minutia over there. Do you get what I'm saying? You're splitting hairs. It doesn't matter what you call it. I'm going to call it X so that doesn't happen again. The missing thing is X. Okay. All right, so 16 plus X squared equals 10 squared is 100. And then what would you do next to keep on? Minus 16. Good. So now we're going to square root. We don't put plus minus with these because it's a side of a triangle and a length can't be negative. All right, but we are going to split that. And I believe it's 4 is the biggest one that's going to work. Yeah, because 84 divided by 4 would be 21. Again, if I get to one where we need a calculator, I'll type it in because I think the next one gets kind of big. But anyway, what would that reduce to? 2 square root of 21 is our answer. That's the missing side. All right, let's try this one. I'll put the X first this time so you can see that it doesn't matter. This would be X squared plus what? 7 squared equals 15 squared. I may need a calculator on the, eventually for this one on one of the next steps. It is good. See, I know that part. This one's 49 and this one's 225. But just so I don't mess up trying to do it in my head, 225 minus 49 gives us 176. And then square root. Are you all making your geometry teachers proud here? Okay. All right, so 176. What do you think goes into 176 that's a perfect square? I'm using a calculator for it. 2 is not a perfect square. Your geometry teacher is very upset right now. It is not 9. It is 16. Good job. 16 times 11. And then it would be 4 square root of 11. This one, and I want you to be a good noticer, you can avoid doing any work if you look at these locker combinations. Do you see 5, 12, 13 is your answer and you don't have to do any work. So that's what I'm saying is if you know those, they save you some time. Okay? Now we're going to do the special right triangles, which are your 45, 45, 90 and your 30, 60, 90. Okay? I'm going to explain to you where the patterns come from. If you don't care and you just want to memorize the patterns and ignore everything else I said, that's fine. But I'm going to show you why they are what they are. So it's not just like magic, right? So this is your 45, 45, 90. And since 2 of the angles are the same, that means 2 of the sides are the same. Do you remember from geometry, these little tick marks mean that they're congruent? Or do you remember that? Okay. Well, it's true. So instead of A, B, C, we get A, C. A and B are congruent. So I just wrote them both as A. Is that, are we together? Yeah. Okay. So when you go to do your Pythagorean theorem, it's A squared plus A squared equals C squared. Combining like terms, perfect. 2A squared equals C squared. And then we're going to square root. Now, square root of 2 is just square root of 2. Like, that's not a perfect square, so you just leave it. What happens with the A, with the squared and the square root? It cancels, so that's just A. And then the same thing over here, that's just C. So if you take the little side and multiply by square root of 2, you get the bigger side. Go ahead. Is it just over 2? That's my bad. I got a little sloppy. Okay. So if you want to go from the smaller side to the bigger side, you multiply by square root of 2. If you want to go from the bigger side to the smaller side, you would divide by square root of 2. So I'm going to write that one as well. And we're going to do just 4 and 5 down here, and then I'll show you the other one. All right, so do you see how this has a 45? That means that's also 45. So 45, 45, 90. So look, if this is 18, that means this side is also 18. Good job. To get from the smaller side to the bigger side, and when I say the bigger side, I mean the hypotenuse. The hypotenuse is always the biggest one. To get from the smaller one to the bigger one, you're going to multiply by square root of 2. Do not overcomplicate this. 18 times square root of 2. There we go. And that's why we have that pattern, like why it's a thing, why we even bother looking at it, is it saves you time. We didn't have to do Pythagorean theorem. We just wrote the answer and didn't do any work. Isn't that great? All right, do you see how this is a 45, 45, 90? It says 45 there. Okay, to get from the bigger side to the smaller side, you have to divide by square root of 2. Now, I will have to actually like simplify that down. This is why I brought up that rationalizing. You're going to multiply by square root of 2. And that's going to give you what? Good. 18 square root of 2 over 2. Thank you. You just like spit that out there. That was great. And then what's 18 divided by 2? This part right here. 9. So this side is 9 square root of 2. And that means that this side is also 9 square root of 2. Because for 45, 45, 90, those sides are congruent. Okie dokie. So now we're going to do the 30, 60, 90. This one's a little bit more complicated. So again, I'm going to go through why it's true. If in the end you just memorize the pattern, that's fine as well. Okay. So the little side, I'm going to call that A. The bigger side is B. C is the hypotenuse. Do you remember how we said small side goes across from small angle? Okay. So So that means this is the 30 degrees. This is the small side across from the small angle. This one's the 60 degrees. Sorry, I can see, or you're trying to see around me. I'll sit down. So what we're going to do for this one is draw a mirror image of the triangle over here so that there's two of them. So I made it equilateral. Remember how you guys brought up equilateral? All sides are the same. So look it. Just watch me point to it because I don't have a better explanation than, hey, look, if this is C, that means this side is also C, and then this side is also C. Like all the sides are C. Do you get what I'm saying? Whoever said A, did you mean this side? Because that's the next thing. Okay, good. That's the next thing I was going to say. You were just ahead of me. So how do you get from A to C? Well, A times, there's two of them, okay? So C equals 2A. So if you take the little side and double it, you get the hypotenuse. If you don't care why, just remember, if you take the little side and double it, you get the hypotenuse. So if you go backwards, instead of multiplying, you would have to divide. So if you take the hypotenuse and divide by 2, you get the smaller side. You just either multiply by 2 or divide by 2. Do you guys understand that if you're trying to make something bigger, you multiply? And you're trying to make it smaller, you divide? So if you try to go from the smaller one to the bigger one, you multiply. If you try to go from the bigger one to the smaller one, you have to divide. All right, now the other one is a little bit more complicated, all right? We're going to do our a squared plus b squared equals c squared. But instead of c, what did we just say c could equal? C, perfect. Oh my gosh, thank you. I did not have to pull teeth there. That was fantastic. And then we're going to just work that out. Okay, so this is a squared plus b squared equals, what is 2 squared? 4, and then a squared is just a squared. And then you want to get all the a's together, so you would subtract over an a squared. 4a squared minus 1a squared, 3a squared. And then to get rid of the squareds, you would square root. Very good. So b equals square root of 3 times a. So do you remember how on the 45, 45, 90, we multiplied by square root of 2? This one you multiply by square root of 3. And that's what we just worked out is the reason why that works. Now that's going from the smaller one to the bigger one. If you want to go from the bigger one to the smaller one, instead of multiplying, you will divide, okay? So b divided by square root of 3 gives you a. Yeah. Do whatever you want. I do, they're on my desk. Take whatever you need. I have another box in the cabinet too, so use them up. They're there for you guys. All right, so now look. You can go from A to C and back again, and you can go from A to B and back again. There's no way to get directly from B to C. Do you see that? Okay, so you have to make a road stop at A. So looking at this one, we are given the bigger side. The reason I know it's the bigger side is because it's across from the 60. So to get from here to here, are we going to multiply or are we going to divide? If it's the bigger side. No, we have the bigger one. We want to get to the little one. Divide. Good. So you're going to take 18, divide it by square root of 3, and then we just have to simplify that down like we did this one. So what are we going to do to simplify that down? Perfect. And well said. You said that well too. So that will give you 18 square root of 3 over 3. And then, oh, good, you said the answer already. This would be 6 square root of 3. Go ahead. Well, it comes from this pattern here. Yeah, that one's square root of 3. And when you're doing the 45, 45, 90, it's square root of 2. All right, and then to get from the smaller side to the hypotenuse, you double it. Do you remember how 2a equals c? You're going to double this. What is 6 times 2? 12. So it will be 12. And then square root of 3 is kind of just there, but we just doubled it. I'm just giving you a different piece of information each time. Look at this one. Which side is this that I gave you? The hypotenuse, good. To get from there to the smaller side, are you going to multiply or divide? Divide. You're going to divide by 2. What's 18 divided by 2? 9. Good. This side is 9. And then to get from the smaller side to the bigger side, are you going to multiply or divide? You're going to multiply by square root of 3. So 9 times square root of 3 is just 9 square root of 3. That's all that is. All right. This time I gave you the smaller side. The reason I know it's the smaller one is because it's across from 30. How would I get from here to the hypotenuse? Multiply by 2. 18 times 2, 36. Good job. And to get from here to here, I'm also going to multiply. Perfect. 18 times square root of 3 is 18 square root of 3. All right, so go ahead and flip over. You all have a calculator for this? Okay. So this is your SOH CAH TOA. It's not any different than it was a couple of years ago when you learned it. Do you remember what sine is? Good. So what does that stand for? Good. Opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Good. And then tangent is opposite over adjacent. Very good. Now, and you need to listen very carefully to this. The calculator is only as good as the person using it. So this will not help you if the things you type are not correct. You all need to go to mode, which is right here next to second. And you need to be in degree mode. If you aren't, literally all your answers will be wrong. Now, you will probably catch it though, because they'll come out to really weird things. Like you'll get something that's 1 degree or, you know, so anyway, you're going to go down, see how radian is highlighted. We're actually going to do radians this year. Next unit, I'm going to teach you what radians are. But what you need to do is go over to degree and just hit enter. Just make sure degree is highlighted.
How do you get out of that?
I'm going to do that. Will you guys just hold on? Let me get everybody to this step. Did you get there? Okay. So you can hit clear to get back to the home screen. Clear is right here. Are you all okay? We're not freaking out because we didn't know how to get out of the menu.
Yeah.
All right. Now, how do you know which side is the opposite and which is the adjacent? I always say the angle that's labeled is your point of view. Do you know how on a map, which you probably don't, you guys don't even use maps anymore because everyone has GPS, but have you ever been at like the mall and they have a map and there's a little star on it and it says you are here? Okay, the one that's labeled is the like you are here. That's your point of view. So the opposite one is the one across from that. Okay, so we're going to find everything that's missing. When it says solve the triangle, it means find everything that's missing. So what I want you to do is first find your point of view. Do you see how this 37 at B is labeled? B is your point of view. And so if you just want to like bold that point, that's the you are here on the map. You are standing there. Good so far? Okay. So that means 11 is the adjacent because the opposite would be across from that. And I don't have that labeled. Do you see that? Okay. So this is adjacent. And what is X representing? So we have adjacent and hypotenuse. So come back over here. Sine, cosine, tangent. Which one has adjacent and hypotenuse? So you are going to write cosine 37 degrees. If you don't put the degree symbol, I don't mark it wrong, but I just want you to understand that's an angle. Equals 11 over X. Now, you have to listen when I explain how to type this, because again, the calculator is only as good as the person using it. Mathematically, here's what's happening. You watch me point to this. You would multiply the X over. So you would have X cosine 37. And then you would divide by cosine 37. So what you want to type in your calculator when X is in the denominator like that is 11 divided by cosine 37. It should look like that. Sine. You'll find it. How many decimal points do you need? 3. The first 3 that you see. Anyone feeling brave? Perfect. So we got x equals 13.773. And I guess actually we don't need to find the other missing side, but I do want to talk about the other missing angle because that's an easy thing to do. What do all the angles add up to? Okay, now listen, because this will save you some time, but are you listening? If they all add up to 180, but this one is worth 90, that means the other two add up to 90. So if you just type 90 minus 37, it'll give you that one that's missing. So what's the one that's missing? 90 minus 37 is 53. Okay, just for what it's worth. We'll just find x for all of these because I don't want to make you do another problem. We're going to already do 4 of them. All right, where is your point of view? That you are here on the map. Hey, good. This is where you're standing. So that means x is the what? Opposite. 13 is the adjacent. So look back up, sine, cosine, or tangent. Which one? Tangent, okay? So tangent of 32 degrees equals x over 13. Now this one's different. Do you see how the one we just did, x was in the denominator? This time it's in the numerator. This one's easier to type. Mathematically, all you would do is multiply the 13 over. And so you're going to type 13 tangent 32. So 13 tangent 32. It's 13 times tangent 32, but you don't have to hit the multiplication. You can if you want to. Perfect. 8.123. And then just for the sake of being thorough, can you tell me what angle B is worth? Yeah, I'll give you a second. So look at number 11. Where is your point of view? Yeah, so A, that's where you're standing. Good. All right, so X is the what? Opposite. Good. 5 is the adjacent. So sine, cosine, or tangent? Tangent. Good. Tangent of 50.1 degrees equals what over what? Close. There we go. Now, all you need to do is multiply the 5 over. So how would you type that? Perfect. I would mark 5.97 wrong. I would only take off half a point, but on the AP exam, they'd give you literally nothing. I don't know what to tell you. If you're going on to AP calculus, if you write this on there, they will give you nothing, 0. You have to do 3 decimal points. So it's 5.979. And again, just for the sake of being thorough, I want us to fill in angle B. Good. And were you able to get this time? Okay. All right. 39.9. You would do 90 minus 50.1. Because if they all add up to 180 and this one's 90, these two have to add up to be 90. So if you do 90 minus that one, you get the other one. All right, where's your point of view? B. Good. That means X is the what? Adjacent. 11 is hypotenuse. Good. Across from the right angles of the hypotenuse. So sine, cosine, or tangent? Good. Cosine. We didn't have a sine on here. Cosine 60 degrees equals what over what? Good. And then how will you type it?
11
And don't, oh, actually that one just came out to 5.5. The reason it did is because that's a 30, 60, 90 triangle. But can you listen to me before you go start doing your delta math? Listen. If X is in the denominator, do you remember how we typed this one? 11. That's why I'm bringing it up again, because I know you probably forgot. If your variable's in the denominator, you have to divide. It's 11 divided by cosine 37. So you have, yeah, it's switched, okay?